Hi guys, this is Mrs. Rooker. We're going to be doing day 8, which is applications, which basically means word problems. And before we get started, I just noticed a little typo. I changed some things around on the notes and I forgot one thing. So on number 1, we have Mrs. Robinson and Mrs. Costello have recently taken up the game of tennis. This is supposed to say Mrs. Robinson lobs her meanest shot to Mrs. Costello, and it can be modeled by the function f of x equals 1/2 or negative 1/2 times x minus 3 squared plus 8, where x is the horizontal distance in feet from where Mrs. Robinson hit the ball, and f of x is the height of the ball in feet above the court. So we are basically just going to graph this function and use the graph to help us answer the questions. So I'm going to graph this first. I really like this. I think you will too, because it's in vertex form. That's most people's favorite form to graph in. So the vertex is going to be opposite same. So it's opposite of negative 3 is 3, and then 8. So 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8. This is a 10 by 10 grid, if that helps you with your counting. So that's the point 3, comma 8. And then the negative in the very front tells me that this parabola is opening downward. And normally I would go over 1, up 1, over 2, up 4, or some teachers do the 1, 3, 5 rule. But instead, I'm going to go down, and I'm going to go down half as much as I normally would. So normally I'd go over 1, up 1. I'm going to go over 1, down 1/2. And then normally I'd go over 2, up 4. I'm going to go over 2, but I'm going to go down half as much as I would. So instead of over 2, up 4, I'm going over 2, down 2, because the negative 1/2 in front is vertically compressing it, so I'm going down half as much as I normally would. Then I'm going to go back to the vertex. I'm going to go over 3. Normally I would go over 3, up 9, because 3 squared is 9. But I am instead going to go over 3, down half as much. So I'm going to go over 3, down 1, 2, 3, 4 and 1/2. Then I'm going to go back to the vertex. I'm going to go over 4. Normally I would go over 4, up 16, because 4 squared is 16, but I'm instead going to go down half as much. So over 4, down half of 16 is 8. I can do that on both sides, but then I want to kind of pause there and think about what this all really means. So let's go back and kind of read up on everything. It says that x is the horizontal distance from where Mrs. Robinson's hit the ball, and f of x is the height of the ball. So if we're at 0, if we're at the y-axis here, this is where Mrs. Robinson hit the ball, because the distance from where she hit the ball is going to be 0 when we're at the y-axis. So I'm going to draw myself a little picture. This is, and I am no artist, so I apologize, Mrs. Robinson, that this picture is not going to be great. But here's the racket, or whatever, and that's her hitting the ball right here. She hits the ball, the distance from her is going to be 0, and the height of the ball is going to be whatever the height is right at this point. So the ball is going to go up in the air. It's going to reach a maximum height at the vertex there, and then it's going to come back down. I'm not going to continue drawing it any further, because this right here represents the ground. So this, it takes off in the air, and then this is where it lands. And then obviously it's going to, bounce or whatever. Or maybe Mrs. Costello will hit the ball before then, and it won't bounce and hit the ground. Who knows? All right, so we graphed the function, and we need to state the domain and range of the function. So this is where it's kind of a little bit up to your discretion. or your teacher's discretion on how we want to describe the domain and range. If we're just doing the domain and range of this parabola, if we have no context, the domain, remember, is how far left and right a parabola goes, and that would be all real numbers, or negative infinity to positive infinity. But we have some restrictions on our parabola. Our parabola starts and stops. It doesn't go on forever. So the domain for this problem would be that it never goes further left than 0. Oops. But it does go to 0, so we put a bracket. And then it never goes further right than 8, because it lands at 8. So that would be the domain. And then the range would be how high up and down it goes. The lowest it ever goes is 0. The highest it ever goes is 8. I just realized something, guys. I should have been paying more attention. I apologize. Domain is how far left and right it goes. I just assumed it was 8. I didn't even count. 1, 2, 3, 4, 5, 6, 7 is actually how far it goes for the domain. So it lands 7 feet away. It doesn't go past there. So the domain is that it stops at 7, and the range is that it never goes above 8. Because the maximum height here is the maximum height here is 8, since this is the vertex 3, 8. All right, but like I said, if this didn't have that context and we were just trying to find the domain of this function, it would be all real numbers, or negative infinity to positive infinity, because it would go on forever. All right, B, in the context of this problem, what does the domain mean? So domain is how far left and right something goes, but we're focusing on the context of this problem. So we're paying attention to the fact that she hits the ball at 0 feet away from the ball, and then it lands 7 feet later. So the ball lands 7 feet from her, or from where she hit it. So the domain means that it's only in the air for 7 feet, and then it lands 7 feet away from her. In the context of this problem, what does the range mean? So the range is how high up and down the ball goes. In the context of this problem, if the maximum height is 8, that means the range is talking about how high the ball goes. So at any given point, in time, the ball is between 0 and 8 feet high, is what the range means. Since range is talking about how high up and down something is, in this problem we're talking about how high up and down the ball is, or what the height of the ball is. What is the maximum height of the tennis ball? So that directly relates to what we just talked about. And if you look at our diagram, the maximum height here is the y-coordinate of the vertex. The maximum height is 8 feet. From what height is the ball hit? So we kind of talked about that when I drew my picture. This is where she's hitting it. The y-intercept here is going to be 1, 2, 3.5. So, since the y-intercept is 0, 3.5, that means that the height where she hit the ball, this is right where she hit the ball, was 3.5 feet. How far away from Mrs. Robinson does the tennis ball reach its maximum height? So what we're talking about here is horizontal distance. Oops, it's not 2 words. I don't know why I made it 2 words. Sorry, guys. Horizontal distance. So, Mrs. Robinson is standing right here, and we're trying to see how far away horizontally the ball travels before it reaches its maximum height, which was up there at 8. So since that was the point 3, 8, that is 3 feet horizontally away from her. If Mrs. Costello is blinded by the sun and does not return the fierce lob hit by, dang it, I have another typo. Here, I thought I did such a good job of fixing the notes, and I did not. So this is supposed to be Mrs. Robison. How far does Mrs. Robison's shot go? So, look at the picture again. For all of these, we're looking at the picture. If Mrs. Costello doesn't hit the ball, then it'll just continue along this path, and it will land over here at the point 7, 0. So that's 7 feet is how far it will go in the air before it lands. All right. If Mrs. Robison is 3 feet away from the net, 6 feet away from the net, which has a height of 3 feet, will the ball even clear the net? Explain your reasoning. So, what I would do on this one is I would kind of imagine where the net would have to be if Miss Robison is standing at the y-axis. So Miss Robison is 6 feet from the net. So if Mrs. Robison is right by the y-axis, the net must be 1, 2, 3, 4, 5, 6 feet away from her. So over here. And the net is 3 feet high. So I'm going to draw the net going up to 3 feet high. And then I have to see if the ball will clear the net there. I'm going to zoom in a little bit here. My picture is actually really messy, so I'm going to kind of redraw some things so that this is more clear. But we had the point 3, 8, and then we were supposed to go over 1, down a half, back to the vertex, over 2, down 2. And then we were supposed to go over 3, down half of 9, so over 3, down 1, 2, 3, 4 and a half. So this is where the ball would be at that time. And the height of the net is supposed to be 3 feet. So this is the net, it's 3 feet high. And the ball looks like it's up here at 3.5 feet. So that means at 6 feet away from Mrs. Robison, the ball is 3.5 feet and the net is 3 feet, meaning the ball does go over the net. Okay. All right, the next one says, what does f of 1 equals 6 represent in this context? So f of 1 equals 6 means we have a coordinate 1, why did I put 4? Sorry, guys. All right, means we have the coordinate 1, 6. So look at our graph and think about, in the context of this problem, so real world situation, what does 1, 6 mean? 1, 6 is this point here, 1, 2, 3, 4, 5, 6. So that means at 1 foot away from Mrs. Robison, the ball is 6 feet high. So at 1 foot away, the ball is 6 feet high. All right, last one for this problem. What is the height of the ball after it has traveled 5 feet horizontally? So try this one on your own really quick. Look at the picture and see how high would the ball be once it's gone 5 feet horizontally. Just pause the video really quick and then I'll tell you the answer. All right, so after you've gone 5 feet horizontally, 1, 2, 3, 4, 5. You're going to be how high? You'll be right here at this point. This is the point 5, 6. So that's 6 feet high. All right, so feel free to pause the video if you need to write down any of this information. And then we'll move on to number 2. Hopefully I'll have fewer typos in number 2. All right, on the next court over, Miss Coates and Mrs. Rooker are also partaking in a feisty game of tennis. Mrs. Rooker's latest shot can be modeled by the function h of t equals negative 1.5t squared plus 3t plus 4.5, where t is the time in seconds that the ball is in the air, and h of t is the height of the ball in feet above the court. All right, so a few things that are different on this one. One kind of obvious thing that's different is this is written in standard form, not vertex form. So it's going to be a little bit longer of a process to graph this. And then the other thing is we're no longer talking about horizontal distance and vertical distance. We're talking about time and height. So, which is essentially vertical distance still, but we're talking about time instead of horizontal distance now. So we're going to graph this. Since this is in standard form, I'm going to do x equals negative b over 2a to find the x coordinate of the vertex. So this is going to be x equals negative b is going to be negative 3 over, over 2 times a, which is negative 1.5. So this is going to be negative 3 over negative 3, which gives us 1. So that's the x coordinate of the vertex. Remember, once you have the x coordinate, you have to plug back in to find the y. So y will equal negative 1/2 times, or sorry, not negative 1/2, negative 1.5 times, we're plugging 1 in every time we see a t. So 1 squared plus 3 times 1 plus 4.5. Y equals 1 squared is just 1 times negative 1.5 is negative 1.5 plus 3 plus 4.5. Negative 1.5 plus 3 is 1.5 plus 4.5. I don't know if you guys have noticed, I think we've talked about it in my class, but when you combine these two, you should always get the opposite of whatever that first number was. So opposite of negative 1.5 was 1.5. Just kind of a good little check. All right, last thing, combine 1.5 and 4.5, we get y equals 6. So the y coordinate of the vertex is 6 when we plug in 1 for the x. So we have a vertex of 1, 6, 1, 2, 3, 4, 5, 6. And I have taught this in class before where a lot of students will say, well, they really didn't hit the ball very far if it already reached its maximum height at 1 foot away. But remember, we're not talking about horizontal distance anymore. We're talking about seconds. So 1, 6 means at 1 second after, who was it that hit the ball? After I hit the ball. 1 second after I hit the ball, the height is 6 feet high, is what this means in this context. But we'll get to that more later. So that's the vertex. And then since it's got a negative 1.5 in front, that means I'm going over 1, down 1.5 in both directions. Oops. Oh yeah, down 1.5. And then I'm going to go back to the vertex. Normally I would go over 2, up 4, but I'm going down because it's negative in front, and I'm going 1.5 times how much I would normally go up. So instead of going over 1, up 4, I'm going to go over 1 and down 1.5 times 4, which is going to be 6. So I go over 1, down, or over 2, down 6. 1, 2, 3, 4, 5, 6. And I'm actually just going to start it here, go upward, and then end it there, because this here, the y-axis, represents where or at what point in time I hit the ball. Since we're now talking about time, we're not talking about distance. That's where I hit the ball. Then it goes up and then lands a few seconds later. All right. So in the context of this problem, what does the domain mean? So the domain I was supposed to find up there, but I kind of ran out of room. So I'll do the domain here. Domain is how far left and right we go. We never go past 0, but 0 is included. And then we only go 1, 2, 3 seconds over. So the domain is 0, 3. And that means the ball is only in the ground or in the air for 3 seconds. All right, now let's find the range. Range is how high up and down it goes, and in this particular problem, it never goes below 0. That's the lowest possible height. So it's 0, comma, the highest height is up here at the vertex, which was had a height of 6. And h of t represented the height of the ball. So the range in this problem is talking about how high the ball is at any given time during this problem. Whoops, that was supposed to be my answer for this. For C is all of that. I'm all over the place today, sorry guys. All right, at what time does the ball reach its maximum height? So that's right here at the vertex, 1, 6 is the maximum height, and the T stood for the time, so that's just 1 second there. So 1 second. What is the maximum height? So that's the y coordinate of the vertex. Right. From what height is the tennis ball hit? So just like on the last problem, we can see that the tennis ball was hit here at the y-axis. If this was the point 1, 6, and this we went over 1, down 1.5. So 1.5 down from 6 would be 4.5. Right. If Miss Coates slips and does not return the shot hit by Mrs. Rooker, how far does the ball go? All right, so think about that for a second. Kind of weird. It says, how far does the ball go? It's a trick question. We're not talking about distance at all here. We're talking about time. So that's a trick question. We do not know, or not enough information for us to know how far it goes. But we do know how long, how many seconds it is before it hits the ground. And that's going to be 1, 2, 3 seconds. All right, and then these are some ugly numbers, but basically this is just the coordinate 2.5, comma 2.625. So let's graph that coordinate, 2.5, comma 2.625. 1, 2.5, 2.6. So that's like somewhere about here. Remember, the x, or I guess the t in this case, was the time, and then the y was the height. So this would be the time, and this would be the height. So in terms of this problem, at 2.5 seconds after the ball was hit, the height of the ball would be 2.625 feet. All right, feel free to pause this video if you need to catch up. Oh my goodness, I'm realizing this was a really long video already. So I'm going to go really quick now and talk about the next couple. Both of the games pale in comparison to the game playing or match taking place with Mr. Naughton and Mr. McGough on the center court. Mr. McGough swings a shot in Mr. Naughton's direction, and he dives to barely hit it a split second before it hits the ground. If Mr. Naughton's shot is modeled by that function, where x is the horizontal distance in feet from where Mr. Naughton hit the ball, and y is the height of the ball in feet above the court, does Mr. Naughton's shot land inside the court if he is 78 feet away from Mr. McGough's baseline? So this one's actually a pretty quick problem. This, you might notice, is written in intercept form, which gives us the x-intercepts of our function. So I'm going to draw a big graph. The x-intercepts are going to be this one. There's nothing being added or subtracted to the x, so this x-intercept is just 0. And this x-intercept is the opposite of negative 78.9, so it's going to be 78.9. Whoops. Over here at 78.9. And it's going to be kind of a long parabola. It's negative, so it's pointing downward like this, which hopefully makes sense since it's that's how a shot should look. So he hits the ball and it lands 78 feet later. If he's standing 78 feet from the baseline, so this is where he hits the ball, and he's standing 78 feet away, then the ball lands 0.9 feet outside the baseline. So his shot is out. Sorry, I didn't spend much more time on that. I should have spent more time on that, but that's okay. The last one, I'm just going to kind of draw a little bit. Oh, I guess there are two more. On the next one, I'm just going to kind of draw a little bit what this should look like. We have a bridge, and I'm not very good at drawing this, but our bridge is going to look something like this, where we have like these towers that they're talking about, and then we're going to have this kind of long parabola. So this is the parabola that we're talking about, and this is going to have a vertex of 1400, 27. And then we're going to use that information and the fact that each tower is 307 feet above the roadway to find out the distance between the two towers. So I'm just going to have you guys work on this on your own if you would like to, and you can pause the video and I'll put some answers up there for you in just a minute. So on number 4, they actually gave you a bunch of information you don't necessarily need. The important thing is you have this function, and it's in vertex form, which was nice. We got our vertex. And then it asks, what is the distance between the two towers? So in this function, if the this vertex, remember parabolas are always going to be symmetrical. So if this is the center of the parabola, or it's the vertex, then it's going to be directly between the two towers. This would be the point, this would be like our x-axis. This is where we're starting. Sorry, our y-axis. Sorry, guys. That's the y-axis. This would be like the point 0, 0. This would be like the point 0, 307. And then if this is all the way over at 1400, 27, that's just halfway between the two towers. So if this distance here is 1400, this distance here will also be 1400. So the entire distance between the two towers is 2800 feet. All right. And then according to the function in this problem, how far above the roadway is the cable at its lowest point? So this one is just the minimum height, which is 27 feet. All right, and then the last one is very similar to number 3. So I want you guys to try that one on your own, and then you can go over that in class with your teachers. All right, have a good one, guys.